it is permissible to run low voltage cable and CAT5e cable in the same conduit. However, you should consider interference and implement mitigation techniques. AC power cables can induce voltage into nearby data cables. Also, AC power cables generate electromagnetic fields that can interfere with data transmission. To mitigate interference, firstly, use shielded cable. CAT5e cables with shielded twisted pairs provide better resistance to electromagnetic interference. Secondly, maintain separation. Keep the two types of cables physically separated within the conduit as much as possible. Thirdly, use conductors of different size. Using larger conductors for the AC power cable and smaller conductors for the CAT5e cable helps reduce AC voltage induction. CAT5e cables use twisted pairs to reduce electromagnetic interference. Avoid coiling or bending the cables excessively, as this can increase inductance and susceptibility to interference. The distance limitations for running low voltage and CAT5e cables together in a conduit vary depending on the specific cables and environment. Generally, for distances up to 250 feet, there should be no significant issues with interference. However, it is recommended to perform testing to verify the performance of the system before installation. Follow National Electrical Code, or NEC, codes and industry standards for running cables in conduits. Use appropriate connectors and terminations for both low voltage and data cables. Label the cables clearly to avoid confusion during installation and maintenance. When dealing with electrical systems, it's important to understand some fundamental concepts such as voltage, current, and resistance. Voltage, measured in volts, is the electrical potential difference that drives current through a circuit. Current, measured in amps, is the flow of electrical charge. Resistance, measured in ohms, opposes the flow of current. These three quantities are related by Ohm's law, which states that voltage equals current times resistance. In the context of running low voltage power and CAT5e data cables, understanding these concepts can help you troubleshoot potential issues. For instance, if you're experiencing voltage drops in your low voltage power circuit, it could be due to excessive resistance in the wiring or an inadequate power supply. Similarly, if you're experiencing data transmission errors in your CAT5e cable, it could be due to electromagnetic interference from nearby AC power cables. Proper grounding is also crucial for electrical safety and minimizing interference. Grounding provides a low resistance path for fault currents to flow back to the source, which helps to trip circuit breakers and prevent electrical shocks. In the context of running low voltage power and CAT5e data cables, it's important to ensure that both the power and data cables are properly grounded. This can help to reduce electromagnetic interference and improve the overall performance of the system. When selecting cables for your low voltage power and CAT5e data circuits, it's important to choose cables that are rated for the appropriate voltage and current levels. Using undersized cables can lead to overheating and potentially cause a fire. It's also important to choose cables that are suitable for the environment in which they will be installed. For example, if the cables will be exposed to moisture or sunlight, you should choose cables that are rated for outdoor use. The National Electrical Code, or NEC, provides detailed guidelines for selecting and installing electrical cables. It's important to consult the NEC to ensure that your installation complies with all applicable requirements. Specifically, NEC Article 725 covers the requirements for Class 1, Class 2, and Class 3 remote control, signaling, and power-limited circuits. These circuits are commonly used for low-voltage power applications. NEC Article 800 covers the requirements for communications circuits, including CAT5e data cables. When running cables and conduits, it's important to follow the NEC fill ratio requirements. The fill ratio is the percentage of the conduit's cross-sectional area that is occupied by cables. Exceeding the fill ratio can make it difficult to pull cables through the conduit and can also lead to overheating. NEC Chapter 9, Table 1 provides detailed information on conduit fill ratios. When making connections to low voltage power and CAT5e data cables, it's important to use appropriate connectors and terminations. Improper connections can lead to loose connections, which can cause overheating and data transmission errors. It's also important to follow the manufacturer's instructions for installing connectors and terminations. Using the wrong tools or techniques can damage the cables and connectors. When installing low-voltage power and CAT5e data cables, it's important to label the cables clearly to avoid confusion during installation and maintenance. Labeling the cables with their voltage and function can help to prevent accidental misconnections. It's also a good idea to create a wiring diagram that shows the location of all cables and connections. This can be helpful for troubleshooting and future modifications. When troubleshooting electrical problems, it's important to follow a systematic approach. Start by identifying the symptoms of the problem. Then use a multimeter or other test equipment to measure voltage, current, and resistance. Compare your measurements to the expected values to identify the source of the problem. Once you've identified the source of the problem, you can take steps to correct it. For example, if you find a loose connection, you can tighten it. If you find a damaged cable, you can replace it. When working with electrical systems, it's important to follow all safety precautions. Always disconnect power before working on any electrical equipment. Wear appropriate personal protective equipment, such as safety glasses and gloves. Be aware of the potential hazards of electricity and take steps to avoid them. If you're not comfortable working with electrical systems, it's best to hire a qualified electrician. A qualified electrician has the training and experience to safely and effectively install and repair electrical systems. They can also help you to ensure that your installation complies with all applicable codes and standards. In this specific scenario of running a 24-volt AC, 5-watt security camera system with CAT5e Ethernet cables, the following considerations are important. Firstly, ensure the 24-volt AC power supply is properly rated and provides adequate current for the cameras. A 5-watt camera at 24 volts AC will draw approximately 0.2 amps. Secondly, use a power supply that is designed for continuous operation and is protected against overloads and short circuits. Thirdly, the CAT5e cable should be of good quality and terminated properly using RJ45 connectors. Fourthly, ensure the connectors are crimped correctly to avoid signal loss and interference. Fifthly, when running the power and data cables in the same conduit, maintain as much physical separation as possible. Consider using cable ties to keep the cables separated. Sixthly, test the system thoroughly after installation to ensure that the cameras are functioning properly and that there is no data loss or interference. Seventhly, if you experience interference, try using shielded CAT5e cable or rerouting the cables to avoid proximity to other electrical wiring. Eighthly, consider using a separate conduit for the power and data cables if interference persists. Ninthly, when installing the cables, avoid sharp bends or kinks, as these can damage the cables and reduce their performance. Tenthly, use cable management techniques to keep the cables organized and prevent them from becoming tangled. 11thly, regularly inspect the cables and connections for any signs of damage or wear. Replace any damaged cables or connectors immediately. 12thly, keep the area around the cables clean and free of debris. Dust and dirt can accumulate in the cables and connectors and reduce their performance. 13thly, when working with electrical systems, always follow lockout-tagout procedures to prevent accidental energization. 14thly, use a voltage tester to verify that the power is off before working on any electrical equipment. 15thly, be aware of the potential hazards of working with electricity and take steps to avoid them. 16thly, if you're not comfortable working with electrical systems, it's best to hire a qualified electrician. 17thly, when running cables and conduits, it's important to consider the type of conduit being used. Electrical metallic tubing, or IMT, is a common type of conduit used for electrical wiring. It is lightweight and easy to install. Rigid metal conduit, or RMC, is a heavier-duty type of conduit that is used for more demanding applications. It provides better protection against physical damage and corrosion. PVC conduit is a non-metallic type of conduit that is used for underground and wet locations. It is resistant to corrosion and is easy to install. 18thly, when selecting a conduit, it's important to consider the size and number of cables that will be run through it. The NEC provides guidelines for conduit fill ratios, which specify the maximum number of cables that can be run in a conduit of a given size. 19thly, it's also important to consider the bending radius of the conduit. The bending radius is the minimum radius to which the conduit can be bent without damaging it. The NEC provides guidelines for bending radii for different types of conduit. 20thly, when installing conduit, it's important to support it properly. Conduit support should be installed at regular intervals to prevent the conduit from sagging or bending. The NEC provides guidelines for conduit support spacing. 21st, when making connections to conduit, it's important to use appropriate fittings. Fittings are used to connect conduit to boxes, enclosures, and other pieces of equipment. There are many different types of fittings available, each designed for a specific application. 22nd, when installing conduit, it's important to seal it properly. Sealing the conduit prevents moisture and other contaminants from entering the conduit and damaging the cables. There are many different types of conduit sealants available, each designed for a specific application. 23rd, when working with electrical systems, it's important to be aware of the potential for arc flash. Arc flash is a dangerous electrical hazard that can occur when there is a short circuit in an electrical system. Arc flash can cause severe burns, blindness, and even death. 24th, to protect yourself from arc flash, it's important to wear appropriate personal protective equipment, or PPE, such as a face shield, gloves, and arc-rated clothing. It's also important to follow safe work practices, such as de-energizing equipment before working on it. 25th, when designing an electrical system, it's important to consider the potential for future expansion. Adding spare capacity to the system can make it easier to add new equipment in the future. This can be accomplished by using larger conduits and boxes than are initially required. 26. It's also important to consider the location of electrical equipment. Equipment should be located in a safe and accessible location where it can be easily maintained. The equipment should also be protected from physical damage and environmental hazards. 27th, when installing electrical equipment, it's important to follow the manufacturer's instructions. The manufacturer's instructions provide detailed information on how to install the equipment properly and safely. Ignoring the manufacturer's instructions can lead to equipment failure, electrical hazards, and voiding of the warranty. 28th, when working with electrical systems, it's important to be aware of the potential for electrical shock. Electrical shock can occur when you come into contact with a live electrical circuit. Electrical shock can cause muscle spasms, burns, and even death. 29th, to protect yourself from electrical shock, it's important to avoid contact with live electrical circuits. Use insulated tools and wear appropriate personal protective equipment, such as rubber gloves and insulated boots. 30th, if you come into contact with a live electrical circuit, do not touch the person who is being shocked. Instead, use a non-conductive object, such as a wooden broom handle, to push the person away from the electrical circuit. 31st, call emergency services immediately. When working with electrical systems, it's always best to err on the side of caution. If you're not sure how to do something safely, it's best to consult with a qualified electrician. A qualified electrician can help you to ensure that your electrical system is installed and maintained safely and properly. For this specific security camera system, make sure the 24-volt AC power supply is rated for the total power consumption of all cameras plus a safety margin, say 20%. This ensures the power supply won't be overloaded. Use appropriate surge protection for both the power and data cables. Surge protectors help to protect the equipment from voltage spikes caused by lightning or other electrical disturbances. Regularly inspect the cables and connections for any signs of damage or corrosion. Replace any damaged or corroded components immediately. Use a cable tester to verify the integrity of the CAT5e cables. A cable tester can detect shorts, opens, and other wiring problems. If the cameras are installed outdoors, use weatherproof enclosures to protect them from the elements. Ensure that the enclosures are properly sealed to prevent moisture from entering. Consider using Power over Ethernet or PoE cameras, which can be powered directly through the CAT5e cable. This eliminates the need for separate power cables and simplifies installation. However, PoE requires a PoE-enabled network switch or injector.